रयत शिक्षण संस्था 17 रोज प्रोजेक्ट 2021-22 for 11 science conducted by Yashwantrao Chavan Institute of Science Satara. Today we are going to learn the next point of our topic, differentiation. Okay, let's see the firstly subpoints of topic differentiation. First one is the relation between continuity and differentiability. In this point, firstly we see the theorem, and its statement is every differentiable function is continuous, but converse need not be true. Firstly, we see its first part and then see its converse part. And then we see examples on it. Okay. The statement of our theorem is every differentiable function is continuous. Let's see proof. Let f of x be a differentiable function. Then by using the definition of by method of first principle, f dash of a is equal to limit as h tends to 0, f of a plus h minus f of a divided by h is equal to dy upon dx at x is equal to a. This is the derivative of function f of x at x is equal to a. Then we have to prove that f of x is a continuous function at x is equal to a. Here, firstly, we consider the function f of x is differentiable. Then we have to prove that f of x is continuous at x is equal to a. That is to prove that limit as x tends to a, f of x is equal to f of a. Then if this condition is satisfied, then we say that the given function is continuous. Therefore, firstly, we prove this. Let x is equal to a plus h. As x approaches to a, then h approaches to 0. Here we take the substitution. X is equal to a plus h. Here x is approaches to a. If x approaches to a, then this h is approaches to 0. We need to show that limit as h tends to 0, f of a plus h is equal to f of a. This is another definition of continuity in terms of h, that is limit as h tends to 0, f of a plus h is equal to f of a. The equation first can be also written as, this equation first also can be written as limit as h tends to 0, f of a plus h minus f of a upon h is equal to limit as h tends to 0, f dash of a. As h tends to 0, but here h is not equal to 0. इथे h value 0 ला approach होते, but exactly not equal to 0 आहे. Multiplying both sides by above equation by h, we get, what we'll get? Let's see. F of a plus h minus f of a is equal to 0 into f dash of a. Then limit as h tends to 0, f of a plus h minus f of a is equal to 0 into f dash of a is 0. Then here f of a is constant, therefore its limit is also a constant. And this term is shift to the right hand side. Finally, we get limit as h tends to 0, f of a plus h is equal to f of a. This proves that the function f of x is continuous at x is equal to a. आता ही कंडिशन प्रूव्ह झाले म्हणजेच काय प्रूव्ह झाले की लिमिट as x tends to a, f of x is equal to f of a, and this is the definition of continuous function f of x. Hence, every differentiable function is continuous. Note that a continuous function need not be a differentiable. The converse of its theorem is every continuous function need not be a differentiable, and we prove this by an example. Okay, let's see this example. Let f of x is equal to mod x be defined on set of real number r. Therefore, f of x can be written as minus x for x is less than 0 and plus x for x is greater than 0, because here is function is the modulus function. Therefore, there are two types of functions, that is two values. Here is minus x or plus x. Consider limit as x tends to 0 minus f of x is equal to limit as x tends to 0 minus, here put the value of f of x is minus x, because here the limit approaches to x tends to 0 minus, that means we take the values less than 0 and approaches to 0. म्हणजे अशा व्हॅल्यूज कलेक्ट करायचे की त्या 0 पेक्षा लेस असतील. मग इथं कुठलं फंक्शन आहे असं की तिथे तुम्हाला काय मिळेल की x च्या व्हॅल्यूज लेस दॅन 0 आहेत, तर ते कुठलं फंक्शन आहे, मायनस एक्स आहे. म्हणून इथे लिमिट as x टेंड्स टू 0 मायनस काय घेतलेलं आहे, मायनस एक्स घेतलेलं आहे. and apply the limit x tends to 0 minus, here apply the limit 0, therefore this limit value of this limit is 0. This limit is called as a left hand side limit. Also here we want to find the right hand side limit. For that, limit as x tends to 0 plus f of x is equal to limit as x tends to 0 plus of x, because here the function f of x is x approaches to 0 plus, that is take the values of x greater than 0. Therefore, the value limiting value of x as x approaches to 0 is equal to 0. Observe that here the left hand side limit and right hand side limit both are equal. Also here find the value of f of 0. Here f of 0 is, if we consider second condition, because here is x is greater than or equal to 0, and equal condition is included in that function. Therefore, f of 0 is equal to say only x, and the value of x is 0, therefore f of 0 is equal to 0. Hence, limit as x tends to 0 minus f of x is equal to limit as x tends to 0 plus f of x is equal to f of 0 is equal to 0. That is, left hand side limit is equal to right hand side limit is equal to the value of that function at x is equal to 0. These three values are equal. Therefore, the given function is continuous at x is equal to 0. आता हे जे फंक्शन आलेलं आहे ते कंटिन्युअस आहे, बट काय नाहीये, डिफरन्शिएबल नाही, हे आपल्याला पुढच्या कंडिशन मध्ये कळेल. Now we have to prove that f of x is not differentiable at x is equal to 0. That is, f dash of 0 does not exist. We have to prove that limit as h tends to 0 minus f of 0 plus h minus f of 0 upon h is not equal to limit as h tends to 0 plus f of 0 plus h minus f of 0 upon h. That is, left hand side limit does not equal to the right hand side limit. That's we want to prove. Okay, firstly find the left hand side limit at x is equal to 0. Here f dash of 0 minus is equal to limit as h tends to 0 minus f of 0 plus h minus f of 0 upon h. Here put the value 0 plus h is h, and then the given function can be written as limit as h tends to 0 minus, as h tends to 0 minus is the value of f of 0 is 0, f of 0 plus h. Here we take the left hand side limit, therefore take the function is minus h, and here h is as it is, cancelling h, that is h get cancelled, it remains only minus 1. The limit of constant is, that is, minus 1. Limit as h tends to 0 minus minus 1 is equal to minus, that is f dash of 0 minus is equal to minus 1. Then we find the right hand side limit at x is equal to 0. Same procedure, f dash of 0 plus limit as h tends to 0 plus f of 0 plus h minus f of 0 upon h. Here we take the values x is greater than or equal to 0. Therefore, we consider the function f of x is equal to x. Therefore, f of h is equal to h. The denominator h is as it is, cancelling both, and the limit as h tends to 0 plus 1 is 1. Hence, the right hand side limit is 1. Okay, here is printing mistake. F dash of 0 plus is equal to 1. Say equation 1, say equation 2. That is clear that from equation 1 and 2, both the left hand side limit and right hand side limit are not same. That the function f of x is equal to mod x is not differentiable at x is equal to 0. Here the left hand side limit does not equal to right hand side limit. And though f of x is continuous at x is equal to 0, but it is not differentiable at x is equal to 0. This is the counter example for function f of x is continuous, but this function is not differentiable. Okay, let's see the some examples on it. First one is the test whether the function f of x is equal to 3x minus 2 bracket raised to 2 upon 5 is differentiable at x is equal to 2 upon 3. Here, इथे काय करायचंय, फंक्शन f of x जे दिलेलं आहे ते टेस्ट करायचंय की डिफरन्शिएबल आहे की नाही at x is equal to 2/3 ला. तर आता हे ऍज युजुअल मेथडने सॉल्व्ह करायचं. त्याचं फर्स्टली काय करायचे, फंक्शन दिलेलं आहे ते लिहून घ्यायचंय. f of x is equal to 3x minus 2 bracket raised to 2/5. Then use the definition of derivative, that is first principal method. F dash of a is equal to limit as h tends to 0 f of a plus h minus f of a upon h. Here x is replaced by a plus h. Note that f dash of 2/3 is equal to 0. F dash of 2/3 is equal to 0 because here put the value of x is 2/3, 3 get cancelled, 2 minus 2 0, and 0 raised to 2/5 is, we will get 0. Therefore, f of 2/3 is equal to 0. For x is equal to 2/3, f dash of 2/3 is equal to limit as h tends to 0. Here put the value of a is equal to 2/3. 2 upon 3 plus h minus f of 2/3 upon h. Here the value of f of 2/3 is 0. Therefore, here only substitute the value of function f of 2/3 plus h. In the given function, x is replaced by 2/3 plus h. Therefore, we will get 3 into 2 upon 3 plus h minus 2 bracket raised to 2/5. Okay, let's see here. 3 into 2 upon 3 plus h minus 2 divided by h bracket raised to 2/5. Then simplify this, multiplying by 3 inside the bracket. 3 get cancelled. It remains only 2. 3 into h is 3h minus 2 as it is divided by h bracket raised to 2/5. 2 get cancelled, 3h upon h, then hh get cancelled, it remains only 3. That is 3 raised to 2 upon 5. Here hh get cancelled. Limit as h tends to 0, 1 upon h, 3 upon 5. And here we apply the limit as h tends to 0, 1 upon 0 does not exist. Therefore, this limit does not exist. Hence, the given function f of x is not differentiable at x is equal to 2/3. Example 2, examine the differentiability of the function is f of x is equal to x minus 2 into mod of x minus 2 and check the differentiability at x is equal to 2. Let's see the solution. Firstly, write the function f of x is equal to x minus 2 mod of x minus 2. As usual method, f of x can be written as minus x minus 2 into 2 when x is less than 2, and if the function for x is greater than or equal to 2, we write the function x minus 2 into 2. Therefore, f dash of left hand side limit f dash of 2 is equal to f dash of 2 minus, that is limit as h tends to 0, minus f of 2 plus h minus f of 2 divided by h. The 2 plus h function can be written as minus into simply replacing x by 2 plus h. Therefore, 2 plus h minus 2 bracket square minus 2, here the value of, directly find the value of f of 2, that is 2 minus 2 divided by h. Here plus 2 minus 2 gets cancelled, it remains only h square, and this value is minus 2 minus 2 0 divided by h. Then in numerator and in denominator h get cancelled, it remains only minus h. Then apply the limit as h tends to 0 minus on minus h. It gives left hand limit of f dash of 2 is equal to 0. Also we find the right hand side limit. Similarly, right hand side limit of f dash of 2 is equal to f dash of 2 plus, that is limit as h tends to 0 minus f of 2 plus h minus f of 2 divided by h. For right hand side function, we take the second function, that is x minus 2 into 2, and here we want to find the function f of 2 plus h, simply replacing x by 2 plus h. Therefore 2 plus h minus 2 bracket square, here is printing mistake, multiply by 2 झालेला आहे, तो इथं ब्रॅकेटचा स्क्वेअर हवाय, minus 2 divided by h as it is, limit as h tends to 0 minus plus 2 minus 2 get cancelled, plus 2 minus 2 0, remains only h square divided by h. h get cancelled, then limit as h tends to 0 minus into h, then applying the limit as h tends to 0 plus on the function h, it will get 0. From the left hand side limit and right hand side limit, it is clear that both the values are equal. Therefore, the given function is differentiable at x is equal to 2. And finally, we say that the given function f of x is equal to x minus 2 into mod of x minus 2 is differentiable at x is equal to 2. Show that the function f of x is continuous at x is equal to 3, but not differentiable at x is equal to 3. If the function is given by 2x plus 1 whenever x is less than or equal to 3, and 16 minus x square for x is greater than 3. Let's see the solution. Write the function f of x is equal to 2x plus 1 for x is less than or equal to 3, and the next function is for x is greater than 3 is 16 minus x square. Firstly, find the value of f of 3, that is find the value of function f of x at x is equal to 3. We use the function 2x plus 1, that is 2 into 3 plus 1 is equal to 7. Firstly, find the left hand side limit. Limit as x tends to 3 minus f of x is equal to limit as x tends to 3. Here use the function 2x plus 1 because here we find the value of left hand side limit, that is x takes the values less than 3, and for less x is less than 3, it is given that the function 2x plus 1. Then apply the limit as x tends to 3. 2 into 3 plus 1 is equal to 7. Then find the right hand side limit. Limit as x tends to 3 plus f of x is equal to limit as x tends to 3. Use the second function, that is x takes the values greater than 3, and it is given that the function 16 minus x square. Here use the function 16 minus x square. Apply the limit as x tends to 3. 16 minus 9 is equal to 7. That is the left hand side limit, right hand side limit, and the value of that function at x is equal to 3 is equal to 7. This clear that the function f of x is continuous at x is equal to 3. The next, we want to here prove the function, that function f of x is not differentiable at x is equal to 3. Therefore, firstly we find the left hand side derivative, that is left hand side of f dash of 3 is equal to f dash of 3 minus is equal to limit as h tends to 0 minus f of 3 plus h minus f of 3 upon h. Therefore, limit as h tends to 0 minus as it is. Here for left hand side limit, use the function 2x plus 1, and then x is replaced by 3x plus 3 plus h. Therefore, 2 into 3 plus h plus 1 as it is. The value of f of 3 is 7 divided by h as it is. Multiply by 2 inside the bracket. It gives that 2 into 3 6 plus 2 into h is 2h plus 1 as it is minus 7 as it is. 6 plus 1 7. 7 minus 7 0. It remains only 2h upon h. That is, here then hh get cancelled and limit as h tends to 0, 2 is equal to 2. That is the left hand side derivative is 2. Also find the right hand side derivative, that is r of f dash of 3 is equal to f dash of 3 plus, that is limit as h tends to 0 plus f of 3 plus h minus f of 3 divided by h. For right hand side limit, we use the function 16 minus x square, that is limit as h tends to 0 plus 16 minus, then x is replaced by 3 plus h. Therefore, write down here 3 plus h bracket square. The value of f of 3 is 7 divided by h. Simplify this expansion. 16 minus 9 minus 6h minus h square minus 7 divided by h. Firstly, expand this bracket and then multiply by minus sign. Then after that we get 16 minus 9 minus 6h minus h square minus 7. Here minus 9 minus 7 is minus 16. Minus 16 plus 16 is 0. That is, taking common minus h inside the bracket, it remains only 6 plus h divided by h. Again hh get cancelled. It remains only the function minus into bracket 6 plus h. Then apply the limit h tends to 0 plus, it gives the value minus 6. And this is the right hand side derivative of given function. From equation 1, the left hand side derivative is 2 and the right hand side derivative is minus 6. Both the values are not equal. Therefore, it is clear that the function f of x is not differentiable at x is equal to 3. Hence, the function f of x is continuous at x is equal to 3, but not differentiable at x is equal to 3. And our last example is, show that the function f of x is differentiable at x is equal to minus 3. For the function f of x is equal to x square plus 2. for x is equal to -3, f dash of -3 is equal to, use the formula of derivative, that is limit as h tends to 0, f of -3 plus h minus f of -3 upon h. Here find the value of function f of -3 plus h. Simply x is replaced by -3 plus h, therefore -3 plus h bracket square plus 2 as it is. The value of f of -3 is 11 because -3 square is 9 and 9 plus 2 is 11. Therefore here write down 11 divided by h. Again expanding this, -3 plus h bracket square, that is 9 minus 6h plus h square plus 2 minus 11. Here again 2 minus 11 is -9. -9 plus 9, 0. That is minus 6h minus h square. Taking common minus h, inside the bracket is 6 plus h divided by h. Again h get cancelled. That is minus into bracket 6 plus h. Then apply the limit, h tends to 0. It remains -6. Therefore, f dash of -3 is exist. So, the function f of x is differentiable at x is equal to -3. Okay. In this video, we see the continuity and differentiability. That is the relation between differentiability and continuity. Okay, let's stop here. Thank you.